Welcome back, everyone. This is Mike again, working on this 2D Space Invaders game. It's obviously been a learning curve thus far, and trying to stay focused on it and keep working on it to completion is another chore. So, anyways, in this video series, what we're going to do is work on the collision detection for the player controller. On the last video, we completed the ability to move the player controller, or the paddle, which is represented by a yellow cube right now, rectangular box. We were able to move it back and forth. And let's replay. Let me just show you if you don't recall where we left off. I'll go ahead and run this. And you'll see we had our enemies spawned, we had our blue defense shields, and we have our yellow paddle at the bottom, which can move. But if I keep going, you see it goes right through the wall on either side. So we don't really want that effect. The reason it's going through the wall is, if you recall, we removed the rigid body component, which normally if you have it on there, it would automatically inherit all the physics capability of Unity. But since we didn't need it, it wasn't something we needed for our player controller, because the movement was, if you recall, the movement was not exactly what we needed. It was starting off slow and they would ramp up faster. We want a more responsive movement, which the way we did it with the box collider and that worked much better just the way it was. We just trapped use the input object built into the API to get user input off the keyboard to be able to move and manipulate this through the transform. So, today we're going to work on making that collision detection work. So, all right, let me bring up the user manual, and let's do a search through here on GameObject, since that's what we're dealing with. Let's see what we have. I've watched a few other videos too. I keep watching videos in between this, and one of the things I remember seeing, which I believe will be useful in what we need to do, is an event called on trigger collider, or on trigger collision, something on trigger. Anyways, it's built into all the game objects. It doesn't require the physics engine to do anything with that. It's more or less just an event that's called when two game objects collide. It has to do with collision detection. And so let's click on GameObject here. I'm going to switch to scripting. That's what we're doing now in the scripting. Let's look at some of these. We've got the properties section, the constructors. We have our public methods, static methods, inherited, static methods, public methods. I'm sorry. I may be looking up the wrong, and I think I am. What I'm wanting is the, let's go back to Unity. Let's stop this. And I'm going to remove the maximize on play. I like to be able to see what's going on here. Also, at the bottom of the screen here, this very last gray bar at the bottom here that you see, where I'm moving my mouse right down near the bottom, it will allow us to, when we're doing our script, we can write a message out to that to show any values or things that we want to be able to see while the game is running. So I'm going to keep it where it's not maximized, so that we can utilize, not only see that, but see the inspector panel and be able to manipulate or modify some of the values, or see what's going on with them in case we're having issues. All right, so let's look at our player. And one thing I did, it was minor, I didn't think I needed to really go over this, is I just dropped the player in and removed the player prefab, since we're not actually spawning multiple players, it's just going to be one. I just put it in there, and we're not going to have that. The only prefabs we have are for the enemies and the shields because there were multiple of the same item. So now let's look at our player and look at the components we have. And we have this thing called Box Collider. And I already checked this is trigger. That's what it was. We needed to, by default, it's not checked. And so one of the things we're going to need to do is use this Box Collider in the collision detection with the wall, since we don't have an actual rigid body that will automatically, based on the physics engine, stop when it hits the wall. So we're going to be using the Box Collider to detect a collision and then act on that collision that's detected. So one of the things we need to do is we need to turn that on and make it a trigger. And what a trigger does is it will allow it to receive basically all the inputs from the physics engine when it collides, but it doesn't actually do anything. It'll continue to pass through. If I say is trigger like that right now, which you saw, I was already moving the paddle when it was checked. But what we're going to do is add an event that will handle that. And so we can still, you can see when we hit the wall, see we're going right through it. So let's go ahead and fix that right now. And the way we're going to do this, we're going to have to go back into our script, our player controller 2 script. So let's jump over to Visual Studio, and I already have it loaded. So and down here we're going to add a new method, the onTrigger, but I need to look that up real quick so I get the correct syntax of it. So let's refer back to our documentation online, and so let's check for it's Box Collider. I think that was 2 words. Okay, there's a Box Collider. And now, okay, is the collider a trigger? So that's what we set. But we're looking for a method or an event. Static methods, operators, message. It's called messages. Events are another, or messages is another term for events. Like I said, I did some C# programming, and it's called events, or you write event handlers. But they have these messages, what are called messages, that will be sent or can be trapped or collected on the scripting side when something occurs. So we've got an onCollisionEnter that's called when either a collider or rigid body has begun touching another rigid body / or a collider. So I guess we could use that. We have an onTriggerEnter. This is called when the collider other enters the trigger. So could use that as well. So, and then onTriggerExit is called when the collider stops touching the trigger. So I think we're going to use the onTriggerEnter. I believe we probably could possibly use onCollisionEnter as well, either one. But since there may be more than one way to do this, is what I'm saying. I don't know. We're going to try the onTriggerEnter first and see what happens. So let's click on onTriggerEnter. It says this message is sent to the trigger collider and the rigid body, if any, that the trigger collider belongs to, and to the rigid body, or the collider if there's no, that touches the trigger. So basically, by us selecting that is trigger, it's classifying that Box Collider component as a trigger. So if anything touches that trigger or Box Collider, this message will be sent to our GameObject that the Box Collider is in, which is our player controller or player GameObject. So let's see, notes. Trigger events are only sent if one of the colliders also has, trigger events are only sent if one of the colliders also has a rigid body attached. Okay, so in order to use this, the collider, which would be another object, they call it other, basically it's another object, it's colliding into, which would be, in the case of our walls, for example, trigger events will be sent to disable automations to allow enabling behaviors in response to collisions. Enter occurs on the fixed update after a collision. The colliders involved are not guaranteed to be at the point of initial contact. Okay, so that's something we're going to need to know, that what that's saying is it could be delayed. I mean, so calculations maybe could occur that could keep that object moving in motion, and so the initial collision, but that message may not be sent immediately, but it's fairly close, I'm sure. We're not doing any heavy duty lifting here with our game here, so this apparently is how we would use this inside our public class, whatever they got a class. This what I'm highlighting right now. Void on trigger, enter, collider, other, destroy, other. There's shown an example to destroy or remove an object, like when you collide with it. If something collides, it'll destroy. We could maybe use that. Maybe it looks like we could use that if we want to destroy one of the enemies, maybe down the road. But when we get to that part, let's work on this. Let's go ahead and look at using that. So it's void on trigger, enter, collider, other. So let's go ahead to our scripting. So we're going to add a void on trigger, enter. I guess it's great. Yeah, with Visual Studio 20, the 2017 edition, so it auto-filled that in. I just hit tab and it started to recognize through the IntelliSense what I needed, and it filled everything in exactly the way we needed it. All right, so we've got that there. So let's just, to make sure that we're actually, this function is being called when we expect it to be. Let's use, there's this thing called debug.log, and that's what I was mentioning earlier. And when you just pass it a message like a string, we could say trigger has been activated. We just want to display a message down in the what you call the debug line or the console in Unity. So let's save that. Let's go to Unity. And so down here in this gray bar, when we run this, when our player controller paddle here hits one of the walls, see there's no message there, but watch when we hit, let's go slow so we can see it happen. Boom. Okay, so we tapped it, and it says trigger has been activated. I don't know if you see that right down bottom left corner of the screen here. It says trigger has been activated. That's the message we displayed. And it's obviously it's not going to show again because it's already there. When I hit this side, I'm sure that would happen as well. Let's stop it and hit play again. Let's make sure it's also occurring when we go to the right. Yeah, so there's nothing at the bottom. You see that? Now let's hit the right wall. Yeah, it works there. So it's triggered on either side. So what we're going to have to do here is we're going to have to control the stop of this paddle in some way. So I was kind of thinking about this. What would be the best way to make that happen? And so we're going to have to probably manually reset the position, basically the transform component of this player controller, to something inside the bounds of the wall, if you get what I mean. And so we just want to reset it. We're not going to allow it to go beyond that wall. So we're going to have to manually control that in some way. So what we need to do, first of all, is determine what those bounds are, what the left side wall, what X value are we is that player controller moving to. before it hits that. And so the easiest way to find out the closest value we can get to make it look like it's really hitting the wall and stopping would be, let's go back into our script, and we're going to use this debug thing again. So the trigger's been activated. Let's go ahead and add something to this where it shows. So we have within this script, because it's tied to our player controller game object, it's tied to our player game object, we can directly, because it's a component also of the player game object, we can access its transform directly with nothing special, just by saying transform dot, and there's should be, let me hit P, yeah, there's a position dot X, so dot to string, and there's this, that'll convert it to a the X value to a string representation that can be with this plus sign. It's called a concatenation. We're combining two text strings. We're combining the text I have here with let's just do this, say X colon, and so this trigger has been activated, period, and it'll say X colon space, and it'll concatenate or add to that string the current value of X. So that's going to give us some good idea without actually looking at, I mean, we could go into here and click on the left sidewall on the right, and we can go ahead and just look at the values there and calculate, you know, okay, this, when we're, first of all, we're moving these cube game objects, the transform values we see are X, Y, Z represent the center point of the object. So same with the walls, because they're both based off of a cube primitive. And so we'd have to do some calculations like halfway across, whatever the width of this is in halfway, and come up with the halfway distance of that, and do some crazy stuff. It's just easier to put that in code there like I did. It'll show what the value of X is at that point when the trigger is first activated. And so we got to move it slow, because it's possible if we keep going through the wall, it keeps getting triggered, because it's happening. Keep in mind, this is happening every frame. You know, every frame that we have. So we're getting like 50 frames a second. It's happening 50 times a second. So we want to kind of move our character as slow as, I mean, our player controller as slow as possible, so we can get that value. So let's go ahead and hit play and run that again. So we'll get our left side, and I'm going to just kind of move that. Now let's do this. I'll tell you what, we're going to click on our scene view here. Take this hand, rotate like that, so we can really see in the scene view, like right about there. That probably would be good. About when it's should be getting close to or getting ready to hit. Let's click back. I got to click the mouse on the game view here for the input to go back to the game. So we're going to go there, 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 and let's see, we're coming close. That is awfully close there, and boom. Okay, I just tapped it. It looks like, okay, trigger has been activated. X is at negative 6.507887. So it looks like 6.5 is probably the, you know, where we're at now. When we're actually moving this paddle, and we're in the midst of a game, and we're, you know, you're really having to move back and forth. I mean, there's going to be some the paddle's going to be moving a lot faster, so it's possible that you know, the value could, by the time it detects and that trigger is sent, the value of X is beyond 6.5. It could be as high as 7 at that point. So we might want to adjust for that. We're going to have to make an accommodation and simulate it hitting the wall by maybe making it fall short just before that wall, not really touching exactly, because I'm trying to think through this in my head and just imagine it. We're triggering that event and it goes through. Obviously, what we want to have it happen is reset the. We have reset the position, but we just want the trigger to happen. As soon as we can. So we don't want it to get all the way to the wall where it's halfway through and in it. We want to allow for time for Unity to process what it needs to and all that. And we don't need much. I'm just saying a little bit, but we'll make a fine-tune adjustment. And so I'm thinking the best way to do that. Initially, we'll put a hard-coded value in the script as a bounds. Well, maybe not. Maybe we'll just go ahead and set it as a public variable so it shows up in Unity here. And that will allow us to kind of tweak it if we have to keep playing and tweaking numbers to get the closest number we can get without going through that wall and causing problems. We'll do that. So let's stop this. Now, the other thing too that we're going to have to, so 6.5, let's just keep that in mind, negative 6.5. I'm going to go ahead and run this. We're going to go the other way and see where the X is when it collides. So let's slide this over this way so that we can be looking here. So as we're approaching, I'm watching the status bar to see when that pops up. I'm really not looking at the game itself. Okay, the trigger was activated. It looks about 6.525348. So roughly it's 6.5 either way. It's going to be at 6.5. So I think we're going to allow for a half. We'll start initially do it less than half. We'll do 6 each way. So we're not getting too close. So let's stop that. Let's go to our script. So we can, for now, we're going to comment out that debug. 2 slashes like that will comment out a line of code. So we're going to do that. You can see it turn green. So that makes that not going to be active when we're running this. So, okay, so what we need to do now, though, is, like I said, we're probably going to have to manually reposition through the transform component, the player controller. But as you can see, our X value is going to be different depending on what direction we're going in. So, luckily we've, this is one thing I pulled out. I pulled out where this input get access horizontal. It actually was, originally we had it pasted in here. And I kind of foresaw that I was going to need to know what direction I was going in. So, I created a private variable here called direction. Type float, so it can accept those floating point numbers in the direction, the negative and positive. And in the update here, which is called once a frame, it actually takes the user input from the keyboard, which is mapped out to what they call the horizontal. That's the X axis. And it assigns it to the direction variable. And then I just use that direction variable in here. The reason I did that because I foresaw that when we get through doing this, I'm going to need to know what direction player controller is moving so we can determine whether it's the left wall or the right wall that it's interacting with. So the other thing we need to think about too is at that moment of collision, when it's triggered, when this is triggered here on trigger enter, how do we know what is the left wall, what is the right wall? There is through some videos I watched and things I've seen, they're doing in some other games and all that. There's a tag system that is built into Unity, which you can apply a tag to certain game objects to identify them in a, like, for a group. For example, the enemies could have like an enemy tag. Player would have a player tag. If you had certain like vehicles, you could have a vehicle tag. But in this case, those examples really relate to general tag that would be one or more than one generally, like vehicles or enemies, you know. But in this case, you can create a tag that's just specific to a single item and call it whatever you want. So let's go back to Unity here. You know, we have our wall, our right and left wall in our scene. And so right now there, if you look, if I click on the right wall, and look at the tag here, it's untagged. So let's drop that down. And these are the tags that are already built into Unity. But we're going to need to add a custom tag for the right wall and a custom tag for the left wall. So we have some kind of tag identifier that we can later use in the script to find that game object by that tag. There's a find game object by tag method that is part of the game object you know, API, if you want to call it that, or Unity. It's basically the main static object for all game objects, and it's like the parent object, but it's it has all this built-in functionality in it. So we want to add a tag for this one. We're going to call this one left wall. And you can put spaces in these. It doesn't matter. It lets you call them whatever you want. You can uppercase all of it, lowercase. Do you know? It's just the tags are you set them up any way you want. So we'll do left wall, and let's add another one. Sorry about that. I had to sneeze, so took the mic off there. Anyways, let's add another one called right wall. Save. So we've got two custom tags, left and right wall. And so let's go back to our gameplay scene here. We got side wall right. And now when we click down tags, you'll see we have two additional tags that have been added, a left wall and a right wall. So this is our wall right. Let's select that one, and then our left wall, select left wall. So that's been tagged that way. So we have two unique tag identifiers for the left and the right wall. All right. I just had to respond to a message on my phone there. Anyway, so we've got that done. Now let's go back to our script right here. So like I said, the game object has this game object. Boom. All right, so let's find that game object. Click game object. Wait for the documentation to load. It's a bit slow here. But public methods, let's see, static methods. Okay, static methods. Okay. Okay, it's find with tag. But you can also find by name. I guess if we did have a unique name. We had wall left or right. I could have used just a regular find static method. But you got find with tag, and see if there's any other methods that might be that. Okay, find game objects with tag returns a list of active game tag. So I guess if we're doing a batch, we might need to use that later when we do some scripting that involves enemies. Obviously, we're going to need to move them like an army back and forth, and so it looks like the find game objects with tag, if we apply an enemy tag to all those enemies, we could get a list of all those game objects, all the enemy objects in one array, one list. We got the find with tag, returns one active game object tag, returns null if no game object was found. static methods. Let's see. What else do we have here? Find objects of type. Type wouldn't work because, like, we'd have to use the type. All our enemies, everything we have put in there, pretty much is based off of a cube type, a primitive type called cube. So we did a find object of type cube. Well, it could return any one of them. So let's see what else we can find. What's this here? Public methods, compare tag. Is this game object tagged with tag? That sounds like something maybe we could use. Let's see. The tag to compare description. Is this game object? Okay, so the example is if, and this is in the void on trigger enter class. Yeah, it's what we're using the on trigger enter. So if other.gameObject.compare tag, I guess that's the tag name player, then you can do something on it. So this is something we probably could use right here. Let's copy that. Seems like it's going to be exactly what we need. Okay, so let's Control V to paste that in. So if other GameObject compare tag, and we called it left while. Let's do just the left while side for now. We'll do that check. We'll worry about the right while after. We can go ahead and just to have it here, because I know we're going to be doing 2 checks depending on what it is. Let's copy our, so if we're going to copy that debug statement we had. We're going to modify it a little bit. Let's say left while trigger has been activated, and it would show that. And let's change that to right while trigger has been activated. So before we do any other additional coding or scripting, let's save this and let's run it. We want to make sure that this is picking up the collisions as we expect on the left and the right. And then we can write, you know, the code is going to be pretty much the same for both, more or less, with a few minor changes. So let's go back to Unity. And again, some of this is trial and error, especially since we've never used Unity before. We're trying to discover some of the functionality. Some of it's going to be trial and error, figuring out what works best. It's sometimes you can do research and find what other people use in a certain instance. One of the things I want to do once I get into this is I will upgrade to the Unity Plus. It's $35 a month, and with that you get the professional courseware and stuff that steps you through. But I think I'm learning as I can go. I can figure this stuff out and learn it. It may be taking longer because I'm having to figure it out, as opposed to going through a course that just says, okay, this is how you do this, this is how you do this, and this is why you do this. You know what I mean? But sometimes self-discovery is the best way to go, and you'll remember it, especially when you make mistakes. It does take more time sometimes. A lot of times, not sometimes, but a lot of times it does take more time because you are going through trial and errors, and but it always sticks with you because you know what you've done, what doesn't work, and what does work. And I think the courseware, taking that later on, would just solidify all my knowledge and what I learned about this. So anyways, enough about that. Let's run this and test this. So what we're watching for down here now is when we hit the left wall, we're going to make sure, yeah, it says left wall trigger has been activated. So we know that worked. Now let's come out here, hit the right wall, and see if that message changes. Yeah, it did. It said right wall trigger has been activated. So we know that that worked. So the collision is actually working. So what we want to do now that we know that part is good, so we have the basic skeleton here for writing the code now. Let's comment out. I like to leave stuff. The reason I comment stuff out is because maybe later on we're having an issue. We want to, you know, display the the X position again, for example, on the left wall or the right wall, and when it collides. And so just leave it in there. We could always take the slashes out. It's easier to take 2 slashes out than to retype all that. So that's why I'm leaving it. Now, let's find out about, we're going to have to modify the transform. So that's how the basic game object, if you look at every object, the transform here, the position, these are properties of the transform. So I'd imagine we can access transform.position and then set the X value to what we want it to encode in order to move it the same way we moved. Let's look at that script. Well, we did transform.translate because we're using a different method there. For that, we're using a vector 3 with a direction and a speed. We're going to manipulate the X directly and just move something, because we're not dealing with any physics on this. Keep that in mind. We're not dealing with any physics, so we're just going to move the controller somewhere. So we said, I think it was -6.5 on the left side. Going that way is as far as we want to really go, but we're going to say cut it off at 6 just to be on the safe side. So if this if statement here is when we collide into the left wall. So let's say transform that position dot, let's see what we have here. Yeah, it looks like we have an X, Y, and a Z. So we probably could access the X, Y, and Z position properties directly. All right, so let's say an X, it's actually a float. It's a vector 3. Let's see, it's a float value. So so we just want to set it to, I guess we just want to set it to a value, right? We said -6 to be on the safe side. F, like that. What's it complaining about? Let's see. The transform. Okay, the position of the transform in world space cannot modify the return value of transform because it is not a variable. Okay, so I can't modify that directly. What about the position? Okay, the position though, this is how you can tell if you can modify something or not. When you hover over like position, that's the actual property of the transform component or object. If you look in the definition that pops up, the little pop-up window, you got a get and a set position. So that means the get is what retrieves the value. So if you need to assign it to another variable or to something, you can get the value. Set means there's a method already built in to allow you to set a value to it. So when I did .x, let's see, and let's hover over that. You see it didn't show that get and set thing on there, which means we're not going to be able to get or set. It's only a get by default. You can't get and set. So it looks like, let's remove that again because it's complaining. If we hover over position 3, see it actually returns as a vector 3 type. So what we're going to have to do, which means we also have to set it back as with a vector 3 variable type. So we're going to have to create a vector 3 here. And we're going to call it basically the new position. We're going to say that the new position is going to be equal to, and initially we're going to assign it. We're going to basically say we're going to assign transform.position to our new variable called new position, which is a vector of type vector 3. So that creates our variable. Now what we want to do is alter or modify the X value only. So new position.x equals -6.0f. Okay, so it let us do that. And then we want to reassign back to position the variable called new position, which is, if you hover over it, if you look, it's showing a vector 3, which matches the type of that, which is a vector 3. And so we can do that. It's kind of like, gotta do it in a 3-step process. You can't really do it directly. So basically what we did there on the first line is we retrieved the current transform position values, x, y, and z, which is, and then assigned it to the new position vector 3 variable. And then we modified it, the x value, to our limit, which we're saying right now is 6. Let's do this, because I did say I wanted to be able to tweak that. Any of these public variables we create up top here, like we have speed, that's defined, it shows up in the Unity interface. So I want to create 2 new floats. One called min-x, and the other called min or max-x. And so we'll set those outside of the scripting area here. We'll set it in Unity, and we'll be able to, once we write the script, we won't have to go back and fool with the script code. We can just change the values in Unity in the exposed public variables we just set up and modify them there. So this is going to be the min-x value, so that's what we're going to assign it to. And I'm going to copy this stuff here because, like I said, the code here for the right wall is going to be essentially the same, but we're going to be assigning it. Oops. What happened? I don't know, something, I guess it just moved my position of where my cursor was. Okay, so we want that new position.x to be max-x when, let me separate these two. So we have 2 separate if blocks here. If the GameObject compare tag left wall, if that returns, you know, if the left wall, well, when we make the collision, if it's the left wall we're colliding into, it'll execute these 3 lines of code. If it's the right wall, it'll execute these 3 lines. Now, if it collides, if our player controller collides into anything else right now, it's not going to be executing any of this code. It'll just check the ifs. The tags won't be a left wall or a right wall, so it'll just ignore it and go on. You know, we're not really to the point where if enemies start moving down and touch our player, I mean, we still got to work that out. That's a whole different script, and more than likely, it will be done probably in this player controller script as well. So this on trigger enter may expand into a little bit more later. But for now, what we're trying to do is just get the collision detection on the wall to stop our player from being able to move the player controller beyond the limits of the wall. Alright, so let's go back to Unity. And my system's just a tad slow. We need to wait till it updates our... We're going to click on the player here. There we go. So we have a min-x and a max-x now showing up. And so, right, they default to the value 0, so we need to go ahead and set that. We said the min-x is going to be -6, and then the max-x would be just 6, +6. Well, the values were 6.5, but like I said, we don't want it to get exactly to the wall, because we could just run into some issues with the on-trigger enter. Well, basically what we're doing, here's what we're doing there with the -6. Once the player controller hits that wall and it collides, we're going to reset the position of that paddle, the player controller, where it's completely outside of the wall. We want to take it outside the wall. But we're starting with a -6 and 6 as our starting point. We're going to tweak those numbers to get as close as possible to the edge of that wall where they're almost touching but not colliding again, to make it look realistic. So when you hit, it kind of stops like as close to the wall as possible. But let's see how this looks. We're going to hit play. And since we have our view, I think, zoomed up here in the game scene, it's on the right wall. We're going to go for the right wall first. I'm going to wait till that loads, okay. And now let's see, as we come up here, see it's getting close, 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 boom. See we hit and see how it bounced away? Boom. If I keep holding the right key, so it's working. It's keeping that from going through. But it's bouncing away kind of, if we just tap it, you can see how far away it throws it. And it's giving it that kind of really jumpy kind of. So what we want to do is get as close as we can to that. So let's see if we can change this view now to look this way. And let's test our left side. There, and let's see, it bounces a little further out. So 6 might be too much. I mean, not enough. We might need to go a little higher. And so let's stop that. And now that, since we didn't really fool with the, since we set the min and max public variables here, we don't even have to go in the script. We can just readjust these two values. We'll add a quarter to each of those, because we know 6.5 was the maximum. Let's do a quarter on those, and let's see how that works. So we're getting close, we're getting close, we're getting close. Yeah, that actually looks better. See, it just barely bounced it out. It's minimized. I don't like the jerkiness though. I would like it to almost stop, like it was like boom right there. So, but the problem is, like I said, when the player is moving to the left really fast, the trigger may happen. Like we can't. The position where the trigger happens may not be the position of where visually where the user is seeing the block, because it could continue to move more in the X direction to the left, the negative direction. So when we reset it, even if we reset it back to the trigger position, there's going to be some kind of jump. But let's see if we can tweak this even a little bit more. So let's see what happens if we go. Let's go to 45 and 40 negative 6.45 and positive 6.45. Let's see what happens. Oops, went right through. What happened there? That was kind of odd. You know, if I'm going really slow, I see it bounce it if I tap. But see, again, if you're holding the left key, the acceleration keeps going, or the movement keeps occurring, even though the trigger hasn't had time to actually execute. And so by that time, to see this paddle, the left side could come through like that before the trigger event occurs, and then we're no longer in there. The trigger, it may not even be executed. So there's not enough time there. So 645 was too much. It still allows it to pass through. It's a matter of playing with these numbers. I don't know. 30. The 25 wasn't too bad. Let's go down to 30. We might have to settle for the 0.25. Oops, that's 20. All right, so let's run that. Let's see what happens on that. Negative 630 for the min X. 630, 6.30 for the max X. Seems to be holding. I'm just holding the left button. A. Could also use there. Well, when I let go, it shot through. That was kind of odd. Yeah, it looks like it. Eventually, because it's. Yeah. All right, so let's. A little bit made a difference, I guess. 25. Let's see. All right, so 25. I'm trying everything to make it go through there. It may be the magic number there. Like I said, this is why it's good to have during, at least during testing, some public variables like this that are in the Unity environment. Now maybe later on they can be moved out, but I don't think it affects the performance. I mean, it's purely a tool by design that when you create public variables, they show up in the editor. It makes it a little bit easier to debug and test, and especially doing multiple iterations like this, trying to fine tune stuff. All right, so we're going to leave it at that. Let's try the right way. I think the 6.25 might work for us. So obviously, boom, we hit that. We're going to stop. Of course, our paddle speed is not really fast. Let's see what happens. And here's the other thing. The speed directly will affect these min and max numbers. So right now we're only moving like 0.1 in increments of 0.1 as you press the key. So that's the multiplier on the speed. If we bump this up to 2, let's see how that. See how that affects our stuff. Maybe the 6.25 will need to be lowered down to 6. So now we can move a lot faster. And that's probably about the speed I think I would want the player controller to be able to move back and forth to avoid any missiles coming down, that kind of thing. But not too fast that it's too easy and out of control. Yeah, let's see what happens when we hit the wall. Yeah, it eventually went through, so we're going to have to tweak those numbers even yet. So it's a trade-off. Slower speed, higher number to get closer to the realistic hit of a wall, or not. So let's just go 6. Again, this is just our first ever Unity game here. We're learning as we go. You know, we can fine-tune our skills as we go down the road. So let's just do a quick test on that. I like to test everything before I move on, to at least know it's somewhat working. I don't want to have a bunch of fixes to do at the end. It seems to be okay. So with a speed of 0.2, our min-x and max-x are set at -6 and 6 respectively. So that seems to be okay. All right, so that, I guess, ends our video here for the collision detection on the player controller. Next, we're going to move on to, I guess we need to start moving our enemies and work on that part. So the next video will be moving around the enemies. Obviously, we're going to use a lot of what we learned in moving around the player controller. We'll use that in our script for moving the enemies. But one thing we won't have, if we look at the script for this, we're getting input from the get access function. Input that get access horizontal. We're not going to be getting input from the keyboard to move our enemies. It's going to be more AI based. It's going to be automatic. So we're going to have to write a script that will move the enemies on the screen. So it's going to be a little bit different. But some of what we learned as far as relocating the position of a game object using the transform, that position will apply. So we'll probably use that. This right here, vector 3 new position. We use a new position, reassign the X, and transform the position. We'll be using those 3 lines of code more than likely in Unity again. So understand those 3 lines. Make sure you know what they do. And anyways, I think it's pretty straightforward. If you have any questions, comments, posted on this video. I am checking daily the comments on any of the videos. So if you have a question or anything that you couldn't hear, I noticed when I listened to some of the videos, my audio was getting choppy, and so I don't know if it's because I've dropped my headset too many times, and it's caused the microphone to get a little shaky, or if it's that I had Discord running in the background. I have a Discord app I use for voice communications as well, and anyways, I shut it off for this video, so when I go back and listen to it, I'm going to check if the audio is clear. Then it's probably because another app was kind of sharing the mic and causing issues. So from now on, I'll probably leave the Discord off and just stream the way I am right now, if that works. If not, I just need to get a new headset down the road or a better mic, which I don't have the money for right now. But anyway, we'll call that an end for this one. I appreciate you all stopping out and watching the video. Hopefully you learned something from it on collision detection and how to set some bounds to simulate, hitting a wall or any kind of other object that's static or that doesn't move within your game scene. So hopefully this all helped. The next thing we're going to move on to again is the enemy movement. So check back. I'm going to take a short break and we'll start that video right up. So if you're watching right now, just stick around. I'll be back with another stream. I just need to end this one so I can have YouTube update the video and we'll start the next one. Till then, y'all take care.